Hi, let's take a look at the atom and study its structure. So, what do we know about the atom? We know that all matter is made up of atoms. Everything and everybody, from very small particles of sand to mountains and rivers and the earth, the sun, the moon, everything is made up of atoms. And we know that the atom is very tiny. To see how tiny it is, let's put a dot here. And let's zoom into this, hypothetically. Let us zoom into this dot. Once you zoom thousands or lakhs of times, you start seeing these kind of structures. Let's zoom into one of them. This is an atom. The atom doesn't look this way in reality, but it's easy for us to understand and grasp the properties of an atom if it is represented this way. So at the center of the atom, we have the protons and the neutrons. The proton has a positive charge, the neutron has no charge, and the electron revolves around this center at great speeds and it has a negative charge. So, how tiny is this atom? Let's say the dot here is 1 millimeter wide. We know that the size of an atom is about 10 to the power minus 10 meters. If we convert this to millimeters, it's about 10 to the power minus 7 millimeters. So what it means is there are 10 to the power 7 atoms or 1 crore atoms in this dot. So just imagine 1 crore very tiny particles in this dot, and that's an atom. That's how small it is. Now let's look at the modern atomic model. At the center of the atom, there is a small but a stable core. This is called the nucleus. The nucleus contains protons and neutrons. All the mass of the atom is concentrated here. So what it means is outside of the nucleus, there is hardly any mass in the atom. The atom consists of three subatomic particles, the protons, the neutrons, and the electrons. Let's take a look at each one of them. The protons are found inside the nucleus. That's here. The protons are positively charged particles, and the protons have a mass equal to 1 AMU or 1 hydrogen atom. We know that the hydrogen atom contains just one proton, and that is taken as a standard to measure mass at the atomic levels, and that is defined as 1 atomic mass unit or 1 AMU. All atoms of an element contain the same number of protons. In other words, the number of protons in the atom defines what element it is. For example, what you see here has 3 protons. So it is a lithium atom. It may contain 3 or different number of electrons, it may contain different number of neutrons, but if it contains 3 protons, it is a lithium atom. Conversely, if the nucleus does not contain 3 protons, let's say it contains less or more than 3 protons, then it is not a lithium atom. So the number of protons define what element it is. The neutrons are very similar to protons. They are found inside the nucleus, that's here. They have a mass equal to 1 hydrogen atom or 1 AMU just like the protons, but they are electrically neutral, that is they don't have any charge. The electrons are very different from the protons or the neutrons. The electrons revolve around the nucleus at great speeds. So what you see here is a elliptical or a circular orbit But in reality, the electrons move around the nucleus in very fuzzy shapes. Like it's more like a bee dancing around the flower or a honey bee hovering around its hive. This is more for just depicting it in a simple way. We write it as an ellipse or a circular orbit. The electrons have negligible mass. When you compare the mass of an electron to that of a proton, it's about 1800 times lighter than a proton. So when we compute the mass of an atom, the mass of an electron is generally ignored. Now you can compare this to when we try to weigh ourselves. When we stand on a weighing machine, we don't try to remove our specs or we don't try to remove the ring that we are wearing because it's negligible. Similarly with electrons. The electrons are negatively charged particles and the strength of the charge is equal to that of the proton. So the electrons are negatively charged, the protons are positively charged, and the strengths are the same. The strength of the charge is the same. And since most atoms are electrically neutral, the number of electrons should be equal to number of protons. So in that way the negative and the positive charges cancel out and the atom will be electrically neutral. So now that we have looked at the structure, let's go back to the statement saying now most of the atom is empty. What does it really mean? Well, the nucleus that you see here is much smaller compared to the size of the atom than what is depicted here. Let's say we blow the nucleus up to the size of a cricket ball. Then the electrons which are at the surface of the atom are 4 kilometers away. Now this is something that you have to imagine. Hold the cricket ball in your hand and tell yourself that you are the nucleus and imagine the electrons 4 kilometers away. So that's how big the atom is compared to the nucleus, or that's how small the nucleus is compared to the atom. Well, now that we have looked at the structure of the atom, let's look at the forces at play inside the atom. Let's begin with a question. We know that opposite charges attract. The negatively charged electron and the positively charged nucleus, they attract each other. So why does the electron not just slide into the nucleus and get stuck, something like this? Or why does the electron just continue in its orbit? Why doesn't it fly away? To answer this, we have to look at the forces, all the forces on the electron. So there is what is called an electrostatic force of attraction between the electron and the nucleus, the negatively charged electron and the positively charged nucleus. But there is also one more force. This is called the centrifugal force. Because the electron goes around the nucleus at great speed, there is a force that pushes the electron away from the center, and that is called the centrifugal force. The balance between the electrostatic force and the centrifugal force keeps the electron in orbit. So that's the story of the electron. What about the protons inside the nucleus? We know that the protons are positively charged, and we know like charges repel, which means the protons should repel each other and move away, somewhat like that. But why doesn't that happen? Why are they held inside the nucleus? So the answer to that question is strong nuclear force. Now, there is a, it's also called a strong force. Now, it's a force that holds the neutrons and the protons together inside the nucleus. So if you go inside the nucleus, this force will be much stronger than the electrostatic force of repulsion between the protons, and hence the nucleus is kept intact. So now we have looked at the structure of the atom, the various subatomic particles like the electron, proton, neutron, and we have also looked at the forces at play inside the atom and how it is kept intact. Thank you.